Okay, we're good. So lesson 2 of unit 15. Unit 15. I don't want to call it day 2 because who knows what day. How are we counting days when we don't have school and sewage and everything else? So lesson 2, only 3 lessons, only 2 more days of new notes in here for the year. So we're getting there. All right, derivatives of exponents. Transcendental stuff, we kind of mentioned that. That doesn't really matter. Let's skip down to these exponent properties to make sure we remember these. xy to the m, like we can sort of distribute that m to both of those. How about x to the m times x to the n? What do we do with the m and the n? Add them. And then you've worked with this already because taking derivatives of powers, we don't like roots. We'd much rather deal with powers. So how to write this as a power? N over m. Should have picked letters that don't sound like each other. Root goes in the bottom, power goes in the top, right? Flower power goes up top, the root grows underneath. Power to a power, what do we do with power to a power? Multiply. X to the 0, 1. X to the negative 1, 1 over x. Easy stuff. We know this, I hope. Although I tutored a kid yesterday who tried to do this property. So what is x squared plus x to the 5th? Right, you can't really do anything with it. You're just stuck with x squared plus x to the 5th. Those are not like terms. Okay. None of those are exponential functions. An exponential function has the variable as the exponent. Hence the name exponential function. Or as part of the exponent. Let's remind ourselves what e to the x looks like. E to the 0 is 1, so there's a good first spot. E to the first is e, which is 2.7 something or other. I mean, preferably you know what the graph looks like, but if you don't, hopefully you can come up with a few points to remember what it looks like. E to the negative 1 would be 1 over e, just 1 over 2.7, which is roughly 1 over 3, like close enough for this picture anyway. So there's our graph of e to the x. The only point we really look for usually is that e to the 0 equals 1. Okay, some limits here. So this is practice. Limit as x goes to negative infinity of e to the x. Look at the picture. As x goes to negative infinity, the graph is headed towards 0. The graph is the best way to do it. But if you do e to the negative infinity, that's 1 over e to the infinity, and that would definitely be 0. Right? 1 divided by something really, 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 really big heads to 0. How about the limit of e to x as x goes to infinity? What's our graph doing? Heading off to infinity. There is a horizontal asymptote of y equals 0. E to the x is never negative. E raised to any power is never negative. It's always positive. Important stuff to know. I don't really want to do the graphical exploring thing. The derivative of e to the x, although this one's kind of fun, the derivative of e to the x is e to the x. So in some ways it's like the easiest derivative ever, as long as you remember the rule. The derivative of e to the x is e to the x. The derivative of e to the u is e to the u, but there's a chain rule aspect that we need to remember u prime on the end of that.
Why is it U prime?
Because it's always, whatever the original rule is, times the derivative of the argument. That's the chain rule. You always chain on the derivative of the argument. We will use the second statement far more than the first, right? Because derivative of e to the x is e to the x, there's not much to that. We use the second one a lot more. Okay, well, what if our base is not e? Do we want to derive all of this? That's a lot of work. Let's skip down to the box, because it's a lot of work to get there, but the result is not really that bad. Derivative of e to the x is e to the x. Derivative of e to the u is e to the u times u prime. Derivative of a to the x is a to the x. You know what? Let's put our other rules over here, because I think this will help us to put them all in one place. The derivative of natural log of x is 1 over x. The derivative of natural log of u is 1 over u times u prime. That's old stuff, but hey, it's been a week at this point almost. Do you remember the derivative of log base a of x? So it's partly the same. It's still 1 over x in the bottom, but there's also a natural log of a in the bottom. And the derivative of log base a of u is 1 over u, natural log of a, times u prime. Again, that's old stuff, but that natural log of a in there is going to help us with the derivative we need today. Okay, logs and exponents are kind of backwards. They're sort of inverse, not sort of, they are inverse functions of one another. So with derivative of log base a, we had a natural log of a in the bottom. Derivative of base a to the x, we're going to have a natural log of a in the top. And if it's a to the u, it's still going to be a to the x times natural log of a times u prime. Okay, you got to know those. Please do not use the power rule on exponential functions. The power rule works for algebraic functions. So x to the fourth, that derivative is 4x cubed, right? Like that's the power rule. People start getting the power rule and the exponent rule confused. Okay, some examples. Derivative of, instantaneous rate of change, also known as the derivative of e to the 4x cubed. Well, e to the 4x cubed doesn't change, but the blow-pop rule is the next level down. I need the derivative of 4x cubed. So that would be 12x squared. Oh, but this one wants me to evaluate it at 1/2. So I'm not done yet. So dy dx at x equals 1/2 is, I'm going to put the 12x squared on the front. Let's see, so 1/2 squared is 1/4. 12 over 4 is 3. 1/2 to the third is 1/8. 4 over 8 is 1/2. So there's my answer. The derivative of e to something is e to something, but don't forget the chain rule. Here's some ones that should be quick and easy. I wonder if they're quick and easy enough to warrant popsicle sticks. Yeah. 3e to the 1/2. Final answer. Okay, popsicle sticks. Let's see. I think I need 6 of them. So in order, hey, you guys that are doing chemistry, time to switch your focus back to pre-cal for a second. Jace, what's the derivative of e to the x? E to the x. Katie, how about the derivative of e to the 2x? 2e to the 2x. So again, it's e to the exponent stays the same, but then multiply by the derivative of the exponents. So Sophia, how about the derivative of e to the 5x? 5e to the 5x. Victoria, e to the negative x? Let's back up. We'll get there in a minute. So e to the negative x, but what's the derivative of negative x? Negative 1. And then you flipped it, which is fine. Negative 1 over e to the x. So you don't have to do that, but not wrong if you do. Cadence, that's a negative 2/3 x there. So what's the derivative of e to the negative 2/3 x?
Negative 2/3 times e to the negative 2/3 x.
Yes. Leah, I think that's a negative x over 2. So what's the derivative of e to the negative x over 2?
Negative 1/2 e to the negative 1/2 x.
Yes. So it's good job, Macy. Seems too good to be true. I guess so. It's just you keep the e the same. Just don't forget the chain rule. Like the chain rule is the only thing to mess you up here. Number 3. If g equals that thing, find the slope of the line tangent to the graph. So that's derivative. Ooh, how are we going to find the derivative of this guy? Quotient rule. So the top is f, the bottom is g. F prime then. Gotta find some more people who are here. Addie, how about the derivative of that top? What's the derivative of e to the 2x minus 1? Good. Jonathan, how about the derivative of the bottom? 2e to the 2x. So I've got my pieces. Now I'm ready to put it together with gf prime minus fg prime over g squared. So gf prime would be 2e to the 2x, e to the 2x plus 1, minus the other way around, fg prime, 2e to the 2x, e to the 2x minus 1. Looks like there's things that would simplify in there. All over e to the 2x plus 1 squared. All right, they've all got the same denominator, so I'm good there. It looks like this is an algebra problem now. If I distribute, what's 2e to the 2x times e to the 2x? It's not 3e to the 2x. What's e to the 2x times e to the 2x? E to the 4x. And then same thing here, minus 2e to the 4x plus 2e to the 2x. This is all algebra from here. So those will cancel. And what's 2e to the 2x plus 2e to the 2x? 4e to the 2x. right? Because I got 2 of them, and 2 more of them make 4 of them. What rule am I going to use for number 4? Product rule, because I got x times e to the x. So the derivative of x is 1. The derivative of e to the x is e to the x. And I'm not being so formal with the product rule because it's a little easier. So it's one of them times the derivative of the other plus the other way around. That's not an answer choice. But if I factor out e to the x, now it's an answer choice. Number 5. Oh, different base. So 3 to some power is still 3 to that power. But chain rule gives me 8x. And then if my base isn't natural log, or excuse me, if my base isn't e, then it's natural log 3 tagged on to the end of that. So let's see if any of these match up. 8x, ln 3, 3 to the, yeah. So different order than I put them in, but same thing. Slope of the line, tangent to the graph. So again, that just means derivative of a natural log problem. This is going to be a massive chain rule problem here. So 1 over the argument, 1 over e to the 3x minus x squared, times the derivative of the argument. So, Aslan, what's the derivative of e to the 3x? 3e to the 3x. And Macy, what's the derivative of x squared? What's the derivative of x squared? Yeah, you do. You should be able to do something else and tell me the derivative of x squared. It is 2 something. That's the power rule, so 2x. And that's fine. I guess we could rewrite this a little bit better. That's correct. I lose sight of the chain rule when I just do u prime over u. I'm used to doing 1 over u chain to the derivative of u. But it is always that. Number 7 and final. Y equals f of x, y equals g of x are shown on the right. If h is e to the f times g, then h prime would be e to the f times g times, now I need the derivative of f times g, so that would be the product rule. So that's fg prime plus gf prime. So at 6, f of 6 is 1, g of 6 is 6, f of 6 is 1, g prime at 6, that would be the slope at 6, is 1/2, g of 6 is 6, f prime at 6 is -1, so I know it's going to be e to the 6th, but they've all got e to the 6th, so I need to do 1/2 minus 6. That would be 1/2 minus 12/2 is -11/2 e to the 6th. So, calculus easy, algebra's hard kind of day. Because the calculus derivative is pretty straightforward. It's all the algebra after that. That's a problem. Okay, today's assignment is worksheet 2. Tomorrow we'll do notes. No, there's not notes tomorrow. Tomorrow we'll just work on worksheet 3 because it's just more practice shuffling them all together.